What's up, everybody? Welcome to the 15th lecture of trig. Today we're going to be talking about the remainder of section 3.1, and we're going to be talking about section 3.2. To start off with, let's talk about the area of oblique triangles. So the area of any oblique triangle is going to be 1/2 times the product of the length of two of its legs times the sine of the angle between those two legs. So to help illustrate what I mean, we've got A and B, let's choose A and B, times the sine of C. So we take the length of these two legs, we multiply it by the sine of the angle between them. And we multiply all of that by 1/2, and that gives us the area. That's all there is to it. There's 3 different forms because we have 3 different combination of legs, but that's all it is. It's the same formula, just different legs that we're using. Having said that, let's look at an example. All right, so for this first example, what we've got is a triangle with one leg that's 90 meters, another leg that's 52 meters, and the angle between the two is 102 degrees. So to find the area of this particular triangle, we would take area is equal to 1/2 times 90 times 52 times the sine of 102. And this is going to be approximately 2,289 meters. Approximately 2,289 meters. Again, it's pretty quick and simple, actually. Compared to some of the other things we've done, to find the area is actually that quick. So let's look at another example. All right, so this next example is a little bit more involved, right? To find the area of this next example, we're going to have to find C and beta. Well, to find C, we can apply the law of sine. The law of sine tells us that 8 divided by the sine of 88 degrees is equal to C divided by the sine of 40 degrees. So to solve this, we multiply both sides by the sine of 40 degrees, and we find that C is equal to the sine of 40 degrees times 8 divided by the sine of 88 degrees. So this is going to come out to be about 5.145 kilometers. So C here is approximately 5.145. Now to find beta, that's a little bit easier, right? To find beta, we just have to add up the other two angles and subtract them from 180 degrees. So 180 minus 88 minus 40 is going to come out to be 52 degrees. Well, if that's the case, then the area of this whole triangle is going to be area will be 1/2 times 8 times 5.145 times the sine of 52 degrees. And that's all there is to it. So what did we do here? First, we applied the law of sine to get the length of C. And then we used the fact that all of the angles inside of the triangle have to add up to 180 degrees. So we were able to find out what beta was. And that's all she wrote. Having said that, let's get into section 3.2 now. So, you're probably looking at this example and wondering, what the hell are we supposed to do here? And if you are good, you should. Because we haven't touched on a problem like this yet. What we want to do is we want to find A, B, and C, all three of those angles, and all we know are the length of our sides. So what do we do? How do we handle this problem? Well, to handle this problem, we apply what's called the law of cosines. Now, what the law of cosines does for us is it gives us a way of relating the length of all three sides to one of the angles. Okay, well, how does it do that? That's the next obvious question, right? Well, it does that through the following relations. We've got a squared is equal to b squared plus c squared minus 2bc times the cosine of A b squared is equal to a squared plus c squared minus 2ac times the cosine of b, and c squared is equal to a squared plus b squared minus 2ab cosine of c. So these three equations form what's called the law of cosine. And like I said, all it's here to do is give us a way of relating the length of all three sides to the angle, to just one angle. Okay. Well, if that's the case, given this triangle, if we want to solve for one of the angles, we can rearrange these equations and set it up to solve for cosine, then use that to find out what the angle is. So let's look at what that looks like. Let's say we decide we wanted to solve for the angle B first. In that case, we want to choose this equation, rearrange it to solve for cosine of b, and then use that to solve for the angle b. So doing that really quick, we've got b squared is equal to a squared plus c squared minus 2ab, my mistake, 2ac times the cosine of b. Well, that means that b squared plus 2ac times cosine of b is equal to a squared plus c squared. All I did was add 2ac cosine b to both sides. That's it. Well, that means 2ac times the cosine of b is equal to a squared plus c squared minus b squared. Now, all we want to do is divide both sides by 2ac. And we've gotten one of the new forms, one of the alternative forms rather, of the law of cosine. That is, cosine b is equal to a squared plus b squared minus c squared divided by 2ac. My mistake. Typo. A squared plus c squared minus b squared divided by 2ac. All right, so we want to apply that now. Applying that, we know that cosine of b is going to be equal to a squared. So that's 8 squared plus c squared, that's 14, the quantity squared, minus b squared, that's 19 squared, divided by 2 times 8 times c. So it comes out to be this mess right here. Well, I don't know what that number is off the top of my head, so I'm going to go back to my notes. That number comes out to be cosine of b is approximately equal to negative 0.45089. Now from here, we can apply our arc cosine and do some massaging and figure out what we've got. or we can go back to the unit circle and approximate it. But no matter what we do, we're going to find that B is approximately 100, well, let me write this out first. B is approximately 116.8 degrees. Holy shit, that's some arithmetic, right? Like, having to do this for every angle is gonna suck. But wait, you don't have to. Now that we know B, we can apply the law of sine to find A or C, and then use the fact that all of our angles have to add up to 180 degrees to find the remaining angle. So you only have to do this big calculation once. After that, you can just apply law of sine and whatever other arithmetic you might want to find the other angle. Cool. So let's look at another example then. So for this next example, all we need to do is solve for A, which means really all we need to do is apply one of the formulas from the law of cosines. Well, if I want to solve for A, the length A, I've got an equation here that solves for A squared. From there, I can just apply the square root and solve for A. So let's apply this. We know from this setup that B is going to be equal to 9. The length C is going to be equal to 12. And the angle A is equal to 25 degrees. So we can just shove those into our equation and get out A squared. Putting those all in, we've got 9 squared plus C squared minus 2 times 9 times C times the cosine of 25 degrees This is going to come out to be 81 plus 244 minus 9 times 12 is going to be 108 times 2 is going to be 216 times the cosine of 25 degrees all that comes out to be a squared. Working all of this through, we're going to get that this is about 29.2375. I went ahead and wrote it on the board opposite of me. That's why I keep looking over my shoulder. So if a squared is about 29.2375, then a is going to be about 5.4. So square root a is approximately the square root of 29.2375, which is about 5.4072. So what did we do here? Well, based on what we had and what we were trying to solve, we chose the equation from the law of cosines that we wanted, and then we solved for, and then we plugged in everything we knew, solved for what we wanted, that missing length, squared, and then took the square root of that. That's it. So now that we've got A, we could find the angles C or B using the law of sine. Cool, let's move on. By now, I'm sure y'all have figured out, mathematicians, we love to be extra. We eat that shit up. As a result, we get this guy named Heron who comes up with another area formula for triangles. And Heron's area formula is equal to the square root of the quantity S times the quantity S minus A times the quantity S minus B times the quantity S minus C. All where S is equal to the quantity A plus B plus C divided by 2. So all these lengths, A, B, C, are the lengths of our triangle. And like I said, this is just another formula for finding the area. Having said that, let's look at an example. All right, so in this final example, all we want to do is apply Heron's formula to find the area of this triangle. To start off with, let's calculate what S is going to be since we're going to use it 4 different times. S is going to be 53 plus 43 plus 72 divided by 2. What that means is all of this is going to come out to be 84. Yeah. So, now that we've got S, we can start plugging things into our radical. We've got, this is equal to the square root of 84 times 84 minus 53, 84 minus 43, and 84 minus 72. Well, I'm not going to bore y'all with working all this out and simplifying it. I'm just gonna go ahead and write it all out. We know this is going to come out to be the square root of 84 times 41 times 31 times 12, which is approximately 1,131.89. So if these were measured in meters, this would be 1,131.89 squared meters. And cool, that is all I've got for y'all today. If you have any questions, by all means, shoot me an email. I know I've got a couple I need to respond back to. Yeah, have a good one, everybody.